mid-1980s, an important urban development took place in the Amsterdam South, Southeast and Schiphol areas. A marked improvement in the infrastructure formed the basis. The motorway network gave access in all directions. The public transport connected Schiphol Airport with the center of Amsterdam and the hinterland. A concentration of internationally orientated companies emerged. As a result, Amsterdam South developed into an important area. It was in this period that the decision was taken to change the former NMB head office into freely divisible areas for rent by various tenants of international standing. And so, one of the most radical office building renovations in Dutch history started. Facades were removed, entire stories disappeared, and a new wing was added to give the building a dynamic image. Originally, it was designed as a landscape office, with the main disadvantage being the vast distance between the center of the area and the windows, which resulted in limited daylight and no privacy. Such areas always have to be illuminated, and there is little contact with the environment. Most people work 20 to 25 meters from a window. Office areas are no longer fashionable. Such areas provide too little privacy for concentrated work. For vastly improved access to daylight, glass facades were installed, and enormous openings were made in the floors and roof, which gave the building its new name, the Atrium. Our previous experience with similar buildings in Sweden and the USA contributed to the selection of Hiensch engineering by the MBO Project Development Company. The engineering required by this large renovation project certainly led to remarkable results. As the new building was equipped with well-insulated facades, the previously installed four-duct system and the constant volume two-channel system became obsolete. Almost all installations were demolished. Only the lift shafts, wiring and ducts remained. 4 extra stories for the installation of technical equipment were added to the original core. This space resulted in a reduction of 57% of the previously essential surface area for technology, creating 1,600 square meters of rentable office space. The heating capacity installed was reduced from 7.5 to 1.6 million kilocalories. The cooling capacity was reduced from 3.6 to 2.8 million kilocalories. The ventilation system was constructed with double ducts for heating and double ducts for cooling. Because of the modern, compact, variable volume system, the ventilation capacity can be reduced from 713,000 to 340,000 cubic meters of air per hour. This system also obviated the necessity of placing radiators in front of the windows. This improved the view and the daylight admission. The atrium has 2 main air conditioning centers, which supplied 27 stories and 1,200 individual office regulating zones. The air-operated cooling machines are cheap to use and maintain. There are also no pathogenic microorganisms, something which can be a problem in the cooling tower basins of the cold water systems. By applying the most modern measuring and regulating technology and the 4th-generation variable volume boxes, the cooling capacity was reduced by 23%. These are all results. results which could only be realized by thinking and working from the building concept. Let us take a walk through this remarkable 45,000 square meter renovated building.
You know, considering I'm actually in a sort of greenhouse here, how is it that I'm feeling so comfortable?
Well, that can be explained in constructional terms, mathematical terms. But the main answer lies in technology.
Ah, yes, of course, technology. But, well, where is it then, this technology?
Everywhere, all over the building. Only you don't notice it. But if you'd care to step into the lift with me and come to the 11th floor.
Lead the way. Nice lift. Quiet too, but 18 persons? Is that safe?
Of course. Just a question of calculation. Each of the 7 personnel lifts in this building can carry up to 1,800 kilos at a rate of 2 meters per second. The installation has been fitted with microprocessor-controlled equipment. And a good thing too. Office buildings know all about rush hours, everybody wanting to get to where he's going as quickly as possible, and the lifts have to be economical.
Ah, the 11th floor. So, this is where the climate control technology is it? But, I can't see anything but boxes.
Now, this is where the air conditioning equipment has been set up. Air conditioning depends on the conditions inside the building and on the state of the weather. At a height of 58 meters, a maximum of 340,000 cubic meters of fresh air is drawn in.
Fresh air? You must be joking. What, here? Next to the highway with all that traffic?
Well, the air is cleaned, of course, filtered through a high-efficiency bag-type filter, which, incidentally, is also used in operating rooms and other areas that have to be kept dust-free. In the summer, the air is dehumidified and cooled by the cooling battery. The dry, cold winter air is humidified and heated. 2 small hot water boilers are enough to heat the entire building.
So what about all that warm air then? Isn't it wasted?
Well, the air does, of course, have to leave the building sometime, but you can retain most of the heat with the heat recovery wheels. The damp, latent heat is transferred to the cold outside air.
Yes. Yes, exchanging hot and cold is very clever. Saves energy as well, but still, that air, how do you get it to sort of move round?
Through ventilation ducts. They're rather like the building's arteries. They branch off again and again until every corner has been reached. The ventilators are more like the heart, pumping the air in and out of the building. And again, the same as the heart, they pump fast under a heavy load and slowly when the load is light. That's why the ventilators operate at variable speeds.
So, when it's quiet in the building, the installations can take it easy?
That's right. Look at where one of the branches of these ducts finishes up. There, the offices. Each office has its own variable volume box. That means it's adjustable. The air is distributed draft-free via the high-induction supply air diffusers attached to the outlets of the variable volume boxes. The variable volume boxes are fitted with a heating battery, which means that the temperature can be turned up or down using the room's own thermostat. The thermostat reacts to the internal heat load, body heat, heat from equipment and lighting. So if it's quiet or there is only a little internal heat, then a minimum of air circulation takes place. And with maximum load, with maximum heat gain from the sun, from people, light and equipment, the maximum amount of air will be supplied to the office.
But why not just open a window? Isn't that a lot simpler?
Ah, but the atrium has its image to think of. The occupants want to be able to work in peace and quiet in the commercial heart of the Netherlands. The glass is insulated, and there's more insulation in the walls and in the completely integrated ceiling system.
I can't see any electric sockets or contact points for my computer or fax and telephone.
Everything has been fitted into the ceiling. The integrated ceiling is supported by profiles. This is where all the cable work is located. Once the office layout is known, what we call energy pillars are set up underneath the profiles. So, you're completely free to arrange and rearrange the office layout without running into any problems. The lighting is particularly suitable for the use of VDUs, visual display units. The window end and the hall end can be switched on and off separately. Time control switching is operated by the building management system.
Building management system? That sounds interesting. What's it for?
The system, or BMS, is really the central nervous system of the building. It measures, regulates and monitors the complete technological installation. The computer section is in the atrium. A data line takes care of the connection between the computer and the substations. The substations keep the entire system at the required settings, while any adjustments are made by remote control. The BMS provides programs for maintenance and energy management. Accidents and emergencies are reported as well. There's a link-up with the fire alarm installation, which means that proper action is taken straight away, like the activation of installations and operating the smoke hatches. Maintenance and control are obviously essential, and so is speedy and proper service. Hiensch Service Company takes charge of the main terminal, day and night.
3 atria. In other words, a pleasant climate through maintaining air circulation when there are constantly changing internal and external factors at work.
Yes, that's right. And there's the usual essentials as well. Toilet and washroom facilities and the resultant sewage, monitoring security and privacy, the need to keep communications going, and last but not least, the striking entrance, the escalator, and the restaurant.
So, that's the atrium. A spectacular renovation project. Autonomous climate control. Well, that must have called for expertise and know-how.
You bet it did.
Hiensch Engineering designed all the technological elements of this building. We would like to thank MBO, the Dutch project development company, who developed the atrium concept, for putting their trust in the vision of Hiensch Engineering, and for granting Hiensch single-source design responsibility.